Welcome to the DIY Honda Garage channel. Welcome to the Diagnostic Troubleshooting Guide for the DTC P16F5, which indicates a high voltage condition in the starter cut relay 1 control circuit for the 2023 Honda CR-V. This code alerts mechanics that the vehicle's powertrain control module, or PCM, has detected an abnormality in the starter cut relay circuit. The starter cut relay's role is to manage power to the starter motor, ensuring it operates only under the right conditions. If the return signal from the starter cut relay is high while the starter is on, it signifies an anomaly that leads to this code being stored. This guide will thoroughly analyze the components involved, possible causes, symptoms, and specific troubleshooting steps that should be followed to effectively diagnose and fix the issue. The DTC P16F5 deals with the starter cut relay, which is crucial in controlling the operation of the starter motor in the Honda CR-V. The powertrain control module, PCM, monitors this relay, and a high return signal indicates that something is amiss in the relay circuit. This could signal a malfunction either in the starter cut relay itself or in the surrounding circuitry. The relay circuit board, which houses the starter cut relay, is typically found under the hood, often near the battery or the fuse box, making it relatively accessible for inspection. Understanding the role of the starter cut relay in initiating the engine's start process is crucial for identifying breakdowns that can affect the vehicle's starting capabilities. The combination of the PCM's monitoring role and the relay's function is central to this diagnostic process. Addressing potential causes for DTC P16F5 begins with inspecting the circuit integrity. A common culprit can be a shorted wire within the starter cut relay circuit that could lead to the high voltage reading detected by the PCM. If the wiring is fine, the next step is to evaluate the relay circuit board. Any fault here can lead to improper command signals that confuse the PCM. Lastly, if the previous checks return normal, it may imply a fault in the PCM itself, making it necessary to conduct thorough diagnostics. Each of these components and connections plays a pivotal role in the functionality of the starter circuitry, and hence, understanding their potential failures is key to resolving the DTC. Several symptoms may present themselves when DTC P16F5 is triggered. First and foremost, a failure to start the engine can be a direct result of the starter cut relay not functioning correctly, as it may not send the necessary signals to engage the starter motor. Additionally, drivers may notice erratic behavior in other electronic components, as issues in one circuit can sometimes propagate and affect related systems. Warning lights on the dashboard may also illuminate, often signaling abnormalities in engine operation. Understanding these symptoms can guide mechanics in pinpointing the issue, emphasizing the importance of a thorough diagnostic approach tailored to this DTC to ensure a reliable determination of the issue at hand. The first step in troubleshooting the DTC P16F5 involves starting the engine. This action allows the technician to check if the DTC recurs, indicating persistent issues. The PCM monitors various parameters once the engine is running, constantly assessing sensor inputs and relay outputs. After starting the engine, the next action is to use a diagnostic tool to check for any stored DTCs. This step is essential as it confirms whether the P16F5 code is actively influencing vehicle operation or if it might be a spurious code that needs further investigation. For the second troubleshooting step, technicians should perform a close inspection of the relay circuit board, specifically targeting the starter cut relay 1 circuit. This involves verifying that the relay itself and its connections are intact and free from corrosion or damage. If the preliminary inspection yields no visible faults, a relay test should be conducted. This test will help identify if the relay is functioning correctly or if it has developed an internal failure that cannot be seen externally. Given the critical role of this relay in engine start operations, ensuring its reliability is crucial in diagnosing DTC P16F5. In the third troubleshooting step, attention shifts to the external circuit related to the starter cut relay, with a specific focus on the ST cut RL1CL line. This involves a detailed inspection for shorted wires or damaged connections that could be causing the high voltage reading detected by the PCM. Any signs of wear, fraying, or exposure of wiring can indicate a fault that may lead to abnormal voltage signals. Perform tests to ensure the line is not shorted to power while the ignition is in the on position. This step is crucial, as any issues within the wiring can affect multiple systems and must be rectified before proceeding to other components of the circuit. For the fourth step in troubleshooting DTC P16F5, if previous inspections yielded normal conditions, the focus must shift to the PCM itself. The PCM, or Powertrain Control Module, serves as the vehicle's brain, controlling engine performance and relay operations. If the previous tests revealed no defects in wiring or the relay circuit board, yet the DTC persists, it is time to conduct a thorough PCM inspection. Ensure that the PCM is receiving proper signals and that its inputs and outputs function as intended. This step will help determine if the PCM has developed internal faults, signaling potential replacement if the component fails to pass diagnostics. The last step in the troubleshooting procedure for DTC P16F5 involves a final repair verification process. After addressing any identified issues with the starter cut relay, wiring, or PCM, all components should be carefully reinstalled. Once this is completed, it's critical to clear any stored DTCs in the PCM using a diagnostic tool. After clearing the codes, run another engine start test to check whether the DTC reappears. This final check is essential in confirming whether the repair successfully resolved the underlying issue or if further diagnostics are still required. To prevent issues such as DTC P16F5 from occurring in the future, regular preventive maintenance is advised. Conducting routine inspections of the vehicle's electrical systems can help identify wear and tear before they lead to failures. Specifically, paying attention to the starter cut relay's wiring harness and connections can help mitigate risks associated with high voltage readings. Cleaning connections and applying dielectric grease can prevent corrosion, thus prolonging the lifespan of these components. A proactive approach to maintenance not only increases the reliability of the vehicle's electrical systems, but also enhances overall driving experience. In summary, the DTC P16F5 points to a high voltage condition in the starter cut Relay 1 control circuit that can impede the normal functioning of a Honda CR-V. Understanding the specific components involved, such as the starter cut relay and PCM, is critical in establishing effective troubleshooting measures. Following the step-by-step diagnostic procedures helps identify and rectify the underlying issues, ensuring the vehicle operates smoothly. Additionally, regular preventive maintenance plays a vital role in maintaining circuit integrity and preventing future troubles. A comprehensive approach, from diagnosis to maintenance, ensures that vehicles run efficiently and reliably. Please like and subscribe to the channel. See you next time.